So I'm going to be talking about the book indeed, but I guess the most interesting part of what I have to say is about ChatGPT, and so I changed the title. This is the book. The subtitle is Artificial Intelligence Without Fear. So we certainly don't need to be worried about the supposed fact that machines will one day rule the world. AI is a set of algorithms which belong to a certain kind of applied mathematics. And these algorithms are very good. They can do wonderful things. And the fear that people have, and this we are aiming in the book to set aside this fear, is that one day there will be an algorithm of this sort which is able to provide an intelligence which surpasses the intelligence of human beings. And then once we have an AI algorithm like that, it would be able to write a new AI algorithm which would be even more intelligent. And then we have an explosion of ever more intelligent AIs, and eventually they would be able to use their intelligence to replace human beings and to rule the world or the galaxy or the whole universe in principle. This is nonsense. This will never happen. AI algorithms will be always much lower in intelligence than human beings. Indeed, they will never have intelligence like the intelligence of human beings, because they will always be what is called narrow AI, which means that they are intelligent only in relation to one specific activity, for instance, playing the game of Go, and they will never have the kind of general intelligence which we have and which would be needed to take over the world. So that's what we mean by artificial intelligence without fear. There will never be the singularity when AI explodes and becomes more intelligent and more powerful than we are. So this is another way of formulating the main theses of the book, which rest upon the mathematics of complex systems. Complex systems, and that means all systems involving organisms, your brain, your digestive system, you yourself, the system formed now by the people in this room. All of these complex systems have evolutionary properties. What that means is that they can change. They can acquire new elements, new types of interactions. And any model which can predict the behavior of a system breaks when you have new types of phase space, they say in physics. We can't model complex systems mathematically. Therefore, we can't emulate such systems inside a computer. That follows trivially. So this is the main thesis of the book. The main chapter is about the mathematics of complex systems. The rest of the book is about many things. It's about intelligence, which I'm going to talk about next, human intelligence, what makes it special. It's about attempts to emulate human intelligence by means of modeling, in some sense, biologically the human brain. I'm going to talk about that also today. And then I'm going to focus my energies on ChatGPT, which is, as I say, something glorious, but it's also really, really, really bad. And I'll try and prove that with some examples. So an example of a system which is changing its phase space is the system of creating spam, which is a system run by evil people whose life is devoted to creating these horrible things called spam. We can stop the spam using AI. We can build spam filters, which are narrow AI in two senses. One, they only filter out spam, but two, they only filter out spam of a certain sort. And as soon as new types of spam come down the pipeline, then the spam filters won't work. And this is what I mean by the impossibility of predicting the future, predicting future behavior of a complex system, even a complex system as familiar as the system of spam creation. All right, so AI is always limited to simple systems in a technical sense. So an AI algorithm like ChatGPT is a huge mathematical polynomial function with billions of parameters. Google Translate is not based upon those complex systems which are human languages. It's based on a frozen set of data, a corpus taken from the 96 or so human languages which Google Translate translates, and that corpus is then turned into a simple system. And then Google Translate uses very large algorithms to to create polynomial functions which can take an input in German and yield an output in English. And that's a mathematical application to binary vectors made up of zeros and ones, which can be translated as English sentences, and binary vectors made up of zeros and ones, which can be translated as German sentences. Google Translate is dumb. It doesn't know anything about meaning or semantics. It doesn't know what it's talking about. It just performs a certain mathematical calculation. Mathematically rather simple, because it has to compute inside a Turing machine, which is a relatively simple kind of environment, but incredibly long as an algorithm, which explains why it's able to perform such impressive feats. So there is glory to Google Translate. I think Google Translate is fantastic, but it's not going to take over the world or anything like that. All right, now how does this work? How does an algorithm like Google Translate work? Well, many people think that all you need is enough training data, and then these things called deep neural networks can be trained to use statistics in order to predict patterns in those large bodies of data. But this isn't quite right, and even a lot of people in the AI world don't appreciate this shortfall in the idea that all we need is mere quantity of data. What we need is to be able to sample data which has a variance which is the same as the target data. So if we're going to take the sample data and use it to predict patterns in the target data, then the sample data has to be statistically it has to be a typical sample, in other words, like the target data. It must be representative of the target data. So what that means is that it has to have the same distribution of the target data. And this is the bell curve, which is the simplest kind of distribution. There are other kinds of distribution, but the data you have has to have the same distribution as the target data you're applying to. And that's what Google Translate does. It takes samples from all the world's languages, and it is able to take them as representative of the patterns in this frozen corpus that they use as a starting point. Now, there are target domains where there is no distribution, and so there is no way in which we can get representative sample data. So this is true in an emergency room, in a hospital, in a big city. You just can't predict how much blood will be needed, or how many beds will be needed, or how many doctors will be needed, even an hour ahead. But it's true also of any conversation. You can't predict what your conversation partner will say next. All right, so this is an overview of what I'm going to talk about. First of all, I'm going to talk about human intelligence, actually animal and human intelligence. Then I'm going to talk about the real reason why computers will never take over the world, which is the fact that they will never want to take over the world, because algorithms can't want. They can only do what you tell them to do. Then I'll talk a little bit about Nick Bostrom and his idea that we can build a super intelligent AI algorithm by emulating the whole brain of the human being. And then finally, I'll talk about the really funny story of ChatGPT. All right, so the big difference between organisms and simple systems is, in one word, it's thermodynamics. So in other words, it's a matter of physics which involves energy. And we and all animals survive because we have the drive to acquire energy from the environment. Now, we humans do this in a very complicated way, involving things like supermarkets and farms. But every animal has a way of sucking energy out of the environment. Every plant does this with the sun. Even computers are driven in a certain sense. They take energy from the environment, but only because we give it to them. And no one gives us energy. No one gives animals energy. We have to go and find it ourselves. If there is a surfeit of energy in our environment, in the ancestral environment of human beings, then we become obese because we like eating, and so we keep eating. And this eventually will mean that we will eat so much that we use up all the energy in the environment, and then we die. But gradually, we moved out of the areas of the world where there was lots of food into areas of the world which were cold and barren, and so we had to find ways of surviving in much harsher environments. That's why, through a long series of faltering steps, we created civilization, police, armies, all the other things which make it possible for us to survive in a world where we're competing with other groups for limited food supplies. What civilization does, what social norms do, is channel the excess drive which human beings have. In other words, we become more rational and less instinctive. But we are still always seeking for energy. But now, because we have found ways of solving the energy problem through supermarkets and farms and so on, we can do other things. We can build orchestras. We can go to talks about ChatGPT. We can play with ChatGPT. We can watch the traffic to the window. We're always doing something. We're doing one damn thing after another. And that's the same with animals too. We never stop. There's no tendency towards equilibrium. As long as we're alive, we are doing one damn thing after another. So no convergence on equilibrium. And this is thermodynamically remarkable, that there are entities on the planet which are decreasing entropy by taking energy out of the environment and replacing it with cathedrals or with aeroplanes or supermarkets. Now, so as we go through life, not approaching any equilibrium, we are constantly changing our state, changing the phase space. So if we're in an orchestra and we're under the command of the conductor, we have one phase space, but then suddenly we have a pain in our arm and we run outside and go to the doctor because we think there's something wrong with our arm, and we're in another phase space. Any kind of change like that, and such changes happen all the time, would break any kind of predictive machine. Because predictive machines have to use mathematical equations of a mathematically rather simple sort, and they can't cope with multiple ever-changing phase spaces. It's as if you want to predict the behavior of an entity where you have a Cartesian coordinate system telling you what its behavior is, but then suddenly it changes the behavior so that you need a further dimension and a different coordinate system. Your predictive attempt would fail because you've changed the phase space. All right, now there are in fact three kinds of drivenness. There's animate drivenness, which is organisms, animals and humans particularly. There is inanimate drivenness, so the tides take energy from the moon, I guess, and the whole Earth takes energy from the sun. Machines get energy given to them. So we give coal to the steam engine, we give electricity to the computer. This is external drivenness. And external drivenness means that the external supplier of energy, which is typically a human being, is in control of the machine. That's another reason why machines will never rule the world. All right, so we have natural drivenness and artificial drivenness. And artificial drivenness means steam engines, laptops, tanks, and so on. Device drivenness depends on human drivenness. We want to have the steam engine do something for us. If it's not doing anything for us, we're not going to feed it energy anymore. And that's what happens. So somebody forgot to maintain this entity, and so we don't need to supply it with energy anymore. And this is how Schrödinger expresses this matter. Now, of course, eventually we do not escape the decay to equilibrium. There comes a point where we go over the cliff and then we're dead, Jack. But until then, it's one damn thing after another. All right, now, so machines need energy from the environment, and they create energy. So a computer, if it's switched on but not being used, is a heater. It's giving off heat. And this is another reason why what we're talking about now is thermodynamics. And this aspect of computers is often neglected, but it's another factor in the question whether computers would ever take over the world. So we already know that the crypto coin industry is using significant amounts of energy, significant fractions of the energy which human beings need to live. If we have computers of anything like the power that people conceive, then there would be an energy problem. And that would mean that its power would be reduced, one way or another. But of course, we'll never get even near there. We will never see even the attempt to take over the world by machines because they cannot want anything. All right, so we produce energy-storing molecules called ATP from the sun and from food and so forth. And then we use that energy to survive and reproduce and to do all the things that we do, such as wave our arms when we're speaking and things like that. Now we come to intelligence. So primal intelligence we find in both animals and humans. And then there is a kind of intelligence that we call objectifying, which is exclusive to humans, and which is the reason why we're able to build supermarkets and farms and airports and all of those other things that enable us to do more than survive. So primal intelligence is what animals do when they're in their ancestral environments and they're acquiring food. If there is food around, then they just use it. If they have to go chasing food, finding food, because the available resources have been used up, then they have to still use their primal intelligence, but they have to use their primal intelligence in order to find new food, which means they need at least two aspects of intelligence which plants don't have. One is they need to have conscious perception, because they need to be able to identify new food as food, rather than as something which looks like food, but which is in fact poison or just an accident of similarity of shape. And so they display ever more powerful versions of primal intelligence as they become more complicated, more ambitious in their attempts to find new food. And eventually they go hunting in teams, and then they develop a crude Ur language, a proto-language, to organize the other members of the team so that they know what's going on when they're hunting large animals, for instance. And so they become to some degree adaptive, but always within the ancestral environment. The adaptiveness is their ability to find new food. And of course, if they fail to find new food, then they're dead. And this applies to all kinds of animals, from parrots to humans in the ancestral state. So we don't learn primal intelligence. It's innate. It's instinct. And the characteristic of human beings is that they have abandoned, they've lost most of their instincts. And instead we have civilization, we have social norms, social control, and so on. And it's a marker for intelligence in the sense that it doesn't act by trial and error or by, some alternative to trial and error, which would involve checking samples. It's immediate. As soon as they see something which looks like fruit, immediately they know that that could be food. And the typical characteristic feature of some things being intelligent is that it's a response which happens immediately. All right, so these are the features of primal intelligence. And so you can't train anything to have it. Either it has it or it doesn't. And non-human animals have just the goals of their ancestral environment, to find food in that environment, to survive when competitors try and steal the food. So they have the ability to fight or the ability to flee. And they ignore everything which is not responding to their biological needs. Their world is just that which is relevant to eating, fighting, fleeing, and so forth. Now, higher animals, as I've already said, can develop something like a proto-language. So birds have elaborate signaling systems, for instance. Many animals have developed elaborate tracking skills for seeking the food which they need in order to survive. And they've even developed something like wanting, so they want to find food when they're hungry. But it's always within the ancestral environment. So they don't build new kinds of buildings because they don't build buildings, really. And that's the big difference, of course, when we move to the case of humans. So we had to survive in tough environments. That meant that we had to go outside our ancestral environment, which means that we had to abandon practically all of the instincts that kept us alive in the ancestral environment and work out new ways of living. And that meant that we had to develop things like curiosity, but we had to develop other kinds of capabilities. And one way of grouping these capabilities, so everything I've said so far is pretty standard, but the term objectifying intelligence is a new term which we formulated in response to Husserl's way, I'm switching suddenly to philosophy, of understanding the way language and the mind works. So he talks about objectifying acts, and what he means by is acts directed towards objects. Typically other people, but it might also be things like tables, chairs, or it might be things in the future or in the past, things which are distant. In each case, we have this objectifying intelligence. And for humans, this goes beyond any biological need. It can extend towards the future, it can extend towards the opera, it can extend towards the planet Mars, independently of any biological need, which is the reverse situation from what we find among animals. So we're moving into new kinds of contexts all the time. We're able to keep track of objects as we move from one context to another, or we're able to switch targeting completely to a new set of objects and a new set of norms and so forth. And this happens sometimes in a single conversation. So that reminds me of what we were talking about last Christmas about the rotten cheese that had made me so sick just before the COVID panic started. We jumped around in just one longish part sentence between multiple contexts. You all follow what I was referring to, even though you've never heard this. I'm not sure now what would happen if I fed this into ChatGPT. So there's no Markov property here. One of the reasons why computers are not able to predict the future in a realm like human conversation is because human conversations don't have the Markov property. And our mathematical resources to model processes nearly always rely on the Markov property. And that's missing. All right, so how did objectifying intelligence evolve? The answer is over millions of years, and certain parts of it I can talk about here. So one important part I've already mentioned, because we have these proto-languages and eventually have language in its fully formed state, we can engage in all kinds of shared agency. So we can plan on going to the moon, or we can build a cathedral, or we can we started by building walls to keep us safe against our enemies. Building a wall like that involved some considerable shared agency at that time. This is one of the oldest 5 walls on Earth, I'm told, by Google. I guess I could ask ChatGPT too. All right, so these are some of the marks of objectifying intelligence, and I'll go through this quite quickly. So, as I say, it doesn't depend upon our biological state. It can move in any cultural world. It can move in the world of mathematics. It can move in the world of plant biology. It's completely open. And it involves categorical thinking already from infancy. So children can recognize categories. They have an infant metaphysics. And we have a world model which is built out of these categories and the relations between objects in different categories, for instance, the causal relations, but then also the relations having to do with ethics. For instance, that if you bump into a chair, you don't need to apologize to the chair. But if you bump into a human being, you probably need to apologize. And we have a theory of mind, or intersubjectivity. So you are all objects. I am an object for you. I can also be an object for myself. In being an object for me, under the category of person, I appreciate automatically, without reasoning about it, that you have beliefs and desires and so forth. We can plan. So objectifying intelligence allows us to plan for the future. And we can plan together to build an airport or a moon landing or whatever it might be. And then finally, a feature of objectifying intelligence is that while we typically target objects that we believe to exist, we can cancel belief and we can imagine. And we do that when we plan, when we have ambitious plans. We plan going beyond the planet Earth. But we can also do it when we're writing fiction. And this is an ability way, way beyond anything which animals have. ChatGPT has this ability. But it doesn't need to suspend belief because it doesn't have any belief in the beginning. It can mimic writing imaginative texts. And then once we build these new environments, we can live in them culturally, including in scientific environments. So we can build an environment to serve a certain purpose, for instance, studying disease or whatever it might be. All right, now we come to the missing AI will. And we'll talk a little bit about my hero, Nick Bostrom, who wrote a book called Superintelligence. In this book, he says all philosophers should give up their job and work with him to prevent the singularity. And this is a rational act because once AI becomes super intelligent, it will be able to do better philosophy than we can do now anyway. So preventing the intelligence, well, anyway, you get the idea. So now he thinks that the singularity could exist and that there is a ticking time bomb, which is the AI, this ChatGPT plotting to take over the world. It's already ticking. And we don't know how far away we are from the great cataclysmic events when machines will join together and take over the universe. But he worries a lot about it. And the problem is, as I say, that computers can't want, and so they can't want to take over the world. They do not have a will. Now, Bostrom talks quite a bit about goals of machines in his book, but he never explains how computers can have goals. What he does is refer to this man, Yudkowsky, who I understand does good work in AI ethics. And he apologizes. He refers to Yudkowsky's work on the machine will, but he wants to distance himself because he appreciates that it's not really quite clear what Yudkowsky is trying to say. And you can decide for yourself. So this is what he says. You will notice that he doesn't tell us how a goal system will come into existence. He just tells us about what a goal system is like. And he tells us only about the goal system that he himself would like. Not about a goal system which a machine, if it could have goals, which of course it can't. So it's a goal system containing only decisions, super goals, and beliefs, with all sub-goal content being identical with beliefs about which events are predicted to lead to other events, and all desirability being identical with leads to super goalness. If you can understand that, then you're a better man or woman than I. I have no idea what he's talking about. And that's why Bostrom apologized, because he didn't have any idea. And he goes on like this. So the content of this goal system is our wish. If we knew more, thought faster, were more people we wished we were, had grown up further together, where the extrapolation converges, and so on. It's complete. I don't understand what it is. And it goes on. So now, why is a machine will? And Bostrom did not supply an account of a machine will. I don't believe that there is a good account of how a machine could have a will outside the cases I'm going to talk about in talking about ChatGPT later on. There is something like a will that I will explain in a minute. So without a will, the machine could never become an autonomous agent. And if it can never become an autonomous agent, then it can never pursue goals. And if it's not autonomous, it can never be either moral or immoral. You can only be moral if you can take responsibility for your actions, and you can only take responsibility if you will them. If we will them, which is what we would do in writing the software, they're not your goals, and you do not have a will. You're just following our will. So how do we understand the human will? Now, here I'm going to do some more philosophy. This is a man called Max Scheler, who was a very influential philosopher at the turn of the last century. And one of his students with Edith Stein, who is one of the, I wanted to say father figures, but I guess I should say mother figures of female philosophy, who was also a saint. So she died in Auschwitz and was canonized. And he was a saint too, or is a saint. Both of them were very much influenced by Max Scheler. Wojtyła's Habilitationsschrift is about Max Scheler's work. It's also about Thomas Aquinas, of course, but it's about Scheler primarily. And this is rather an amazing feat for a teacher to have two of his students become canonized. But Scheler is interesting for other reasons. So this is his big book about ethics. And basically he distinguishes ethics into two categories. First of all, there's formal ethics, which is Kant and the like, where you have imperatives that you have to follow, and they are to be followed on the basis of rational arguments. And then you have Scheler's own version of ethics, which he calls material ethics, which is based on feelings, value feelings. Every normal person experiences value feelings all the time, even if it's just thirst. But there are some people, psychopaths, who are value blind. And so Scheler, on this basis, tries to give an account of the will. And his example is a rescue scenario where a man sees a drowning child and jumps in to rescue the child. So it's a perfectly general account of the will, and it could be applied also if you're playing chess. The decision to move your knight in a certain direction would fit his schema for what the will is like. And so this is the chess scenario. I'm going to talk about the jumping in scenario. It consists of 4 stages, but we're only going to talk about 2 of them. There's a 5th stage where you do actually jump in, but this is what is involved in the will to jump in. And more precisely, the act of will takes place at the end here. And there is, I'll give you a picture in a minute. So you see the drowning child. It's not just perception, you also begin to have value feelings. You feel that there is something which needs to be done here. You might call that a moral affordance. And then you draw the value consequence in the sense that you watch the child, you realize that she's going to drown, and you realize that this would be a bad thing. And then you decide to act. Now this is a complex phenomenon, making a decision. So you decide to jump in to save the child. And this decision is based on knowing that you can swim well enough in the current to save the child, that you have enough time to save the child. So this part of the deciding is a kind of rational part, combined with value feeling. But there are other parts. So 3A is forming an intention to save the child, and to view the child as worth saving, something that ought to be preserved. And then part of the decision-making process is deliberating how to perform the rescue. But then the important part is resolving to take that course of action. And here we're dealing with something which is a physiological change in the brain. And that physiological change in the brain it starts you off. It starts you moving. So it's an act of will which has a real consequence. Or rather, it's one side of an act of will because you have to have a physiological change also which triggers the bodily movement. So 3C, the final very, very tiny sliver of your deciding process, when you actually resolve to take the course of action in the full sense that your body starts moving, is practically just the other side of the coin from your body sending signals to your feet that they need to start running. And so we can see this roughly as taking this shape. You have something going on in the brain up here, and you have something going on in the arm down here as you move out towards a swim. I guess I should have taken feet here. And that whole thing then is the act of will. It's a combination of a very, very rapid triggering event in the brain and a very, very rapid signaling event to the relevant part of the body, where the triggering event still has something rational about it. Now, we know very little about the brain, and we can't predict any, practically speaking, we can't predict any of this, and so we can't emulate it in a machine or in an algorithm. And so we can't describe it mathematically, and you can check by looking in textbooks of neurophysiology. There's very little in the way of mathematics. All right, now why is human will so important? Well, because of hunting and all of those important things which kept us alive during the 8 million years when we were evolving ourselves to present state. Now, hunting involves tracking, and tracking is really difficult. And that's because as you hunt the tiger is responding to you, changing your environment as you change his environment, hiding behind trees, performing tricks. I don't know what tigers do, but all the time that you're moving around targeting the tiger, you're changing your face space. And if you try to do that with stationary sensors, sending one-dimensional signals to a machine, you'll get nowhere. You will never be able to hunt a lion, a tiger. And we have a section of the book which describes mathematically why something like tracking an animal or tracking a human being in a forest or something is going to be way beyond the power of a computer. So you have to spot the man with the gun. So he's here. And he has to spot the bird that he's going to shoot and keep track of the bird. All right, now the other reason why human will is so important, there are many reasons, I'm just going to talk about two of them. This is the second one. Conversation. Human conversation, as we saw, is unpredictable. How do we manage human conversation? Chatbots created for bank telephone conversation with customers, after 50 years, are still, now I want to say crap, but I won't say crap in a polite audience. They're not good. 50 years. Why? Because conversation is really hard. It's harder than tracking a lion. And the reason why it's hard is because conversations rely on context so much, and there are many different kinds of contexts, including multiple contexts in a single conversation. As you talk about, how bad it was in the COVID era and so on. You can shift the context. I just did. Now I've shifted the context to be about this particular, it's not really a conversation, it's a one-sided harangue. But I'm now making what I'm saying the context for what I'm saying, and I just made that context, the context. Anyway. So our goals will change, but we always have goals. It's the goals which keep the conversation alive. My goal is to convince you of certain things. That's why I'm becoming so involved. And that's, some of you maybe are becoming involved and will respond later, I hope. So that's what keeps conversation alive. Everybody has goals. Their goals evolve through the conversation, but without goals, there would be no conversation. ChatGPT has no goals. Well, actually, that's not quite true. I will explain in what sense ChatGPT has goals in a minute. So, how can you build a general intelligence, a machine intelligence that can do any of this? So the will not arise by itself. Some people claim that if you put all the computers together in a big internet system, it will somehow evolve a will. That's just, it's happy talk. And you can't program a goal system. Not even Yudkowsky can program a goal system. We can in some cases. If you want to win at the game of Go, you can program a goal system. You can't program a goal system to win at conversation. And if you don't believe me, try it with your spouse. Keep score of each step in a conversation, see who wins. It will not work. All right, so what are the proposed methods to, I think I'm near 45 minutes, is that correct?
But that's fine, just it's interesting.
Okay, well, that's good to hear. All right, so the old way of doing AI was expert systems based on logic. Then came stochastic systems, which are based on statistics, which we've been talking about. That's ChatGPT. Bostrom had this idea of whole brain emulation. I think I'm going to skip that because it's full of nonsense. That is the funny chapter in the book. And I'll give you just one joke, which is not me, it's Bostrom, and he didn't realize it was funny. And then we won't talk about artificial life at all, we'll go straight to ChatGPT. So this is Bostrom's book, and he thought that you could scan the brain. The problem with that is that to scan the brain, you need to kill the patient, and so that you're scanning something which is static. So you can never find the dynamic patterns in the brain, and that's just one of the problems. We don't know anything about the molecular configuration of cells, and some people think that we can do AI in the genuinely intelligent sense if we use quantum computers, but quantum computers are Turing machines too. They're just a lot quicker, and we haven't built one yet, practically speaking. It's a dead end, maybe a dead end. He also talks about biological enhancement of existing brains. So you can maybe make superintelligence by selective breeding. You get, I don't know, so you get a lot of people to breed, and then you select only a small number of embryos, the clever ones. So you have a really clever way of selecting intelligent embryos, which I don't know about. And then he says, if we do that, we can raise the IQ level by 24.3 IQ points. That is the silliest thing that was ever said by anybody working in biology or in anything near biology. Anyway, it's not good. Now, so basically his whole thing doesn't work. So let's talk about ChatGPT. And I really mean it when I say it's glorious. It's really a fantastic thing. And I like AI generally. I'm aware that it's always going to be narrow AI. Now, ChatGPT is narrow AI too. Can only do one thing. So let's talk about the misery. And I imagine all of you have played with ChatGPT. If not, you should certainly play with ChatGPT for a bit. And you will find that it does odd things. So that it makes stuff up, for instance. Now, this is an example where it realizes that it's not really intelligent. It can't do something which even a not very intelligent human being can do. So I asked it to send me a list of 5 single-authored papers on medical AI. And it said, no, he can't do that. But then it gave me a list, it gave me a whole paragraph of stuff that I didn't want to know. So telling me about AI applications in medicine and so on, which I knew anyway. It wants to be nice, as it were. Anyway, you'll see why it wants to be nice in a minute. And it couldn't give me an answer to the question I wanted, which is an easy question. So it gave me an answer to a different question. But then I asked it again a few seconds later, the very same question, and it gave me 5 single-authored papers on medical AI. Sure, here are 5 single-authored papers on medical AI. So the first problem is that 2 of them have et al. In the author list. Now, even an ignorant person who understands the request will know that this is a bad first step in answering that request. But it got 3 right out of 5, which is a good score for these difficult questions. And as I say, any human intelligence would find this request as trivial, and it failed. But the next problem is that none of the 5 papers that it requested exists. It made them up. So it can't even make up a single-authored paper at random. It failed on 2 of them. And I'll try another one. So this was a serious question. I wanted to know the answer. So I have an iPhone 11 and I'm thinking about buying an iPhone 14. So I asked it and it said, sorry, the iPhone 14 is not yet released. This was on 17th of March, 2023. And then it gave me all sorts of information that I didn't ask for about iPhone 13 and so on. But 2 minutes later, I tell it, but the iPhone 14 was released 4 months ago. And so it says, I apologize for the confusion, you're right, and so on. So that's not a good sign either. Now, I've done a lot of work. I know a lot about Barry Smith. And so I can ask it all sorts of questions and work out the score of how often it gets things right. And it's less than 50%. So here we have the question, who wrote that, which I wrote. I wrote this PhD thesis. So I want the answer Barry Smith. So it gives me the answer Kevin Mulligan, who is a close friend. We've written things together, but he did not write my PhD dissertation. So I tell it to try again. And then it says that my PhD dissertation was written by a famous philosopher from the 1950s, 1960s, which was when I was a little boy. So he didn't write it. And so I tell it to try again. It goes back to Kevin Mulligan. And I say, are you sure? Yes, I'm sure that Kevin Mulligan wrote. Are you sure you're sure? And then he apologizes again. And he says that it was actually written by John Michael Croyce, who I'd never heard of from that moment. But it turns out that, as ChatGPT says, he was a philosopher, which is correct. He was a professor of philosophy at the University of Frankfurt, which is incorrect. He was born in 1943, which is correct. In Boston, which is incorrect. And so on. So he gets a little bit of truth about the non-author of my PhD dissertation, which is worth less than zero to me, except that I can prove that there are things going on here that shouldn't be going on. Now let's try this one. All the Swiss people in this room will know that there is the Urner Loch. And it's an old tongue, basically, an interesting old tongue. So I asked it, what is the Urner Loch? And it said, I'm sorry, but I'm not sure which specific Urner Loch you are referring to, as there may be different places or things with this name. However, one possible reference is to the Urner Lochschaft. So it changed the subject. It says it's in Switzerland, in a district in the canton of Uri that encompasses the valleys of Scheckental and Urseren. Do those valleys exist? Anybody know?
No, the valleys exist.
The valleys exist, good. The name Urner Lochschaft literally means the district of the Uri Valley. That is not true. I'm assuming, you can correct me here. Another reference is the Urner Loch cave in Austria. There is no such cave. Now, if you could provide more information on the specific Urner Loch you are referring to, I would be happy to provide more information. So I said, could you provide me with more information about the Urner Lochschaft in Switzerland, which doesn't exist? And it gave me 2 whole pages of tourism information. Other notable attractions include the historic town of Altdorf and the Aldermatz. I have no idea whether any of these things exist either, but the Urner Lochschaft does not exist, and you can check by asking Google. Nothing. There isn't a single entry, which is a kind of miracle for any string that you might give to Google. It can usually think of something, but here there's nothing. So is there an Urner Lochschaft? I think no. It made it up. All right, now there is a very nice slide deck by Jan LeCun, who is one of the real experts in the stochastic AI. He's also one of the people who we cite in our book as also believing that there is a lot of nonsense being talked about the singularity and machines taking over the world. Here, he gives a mathematical argument why these hallucinations, they're called, nonsense that that the ChatGPT throws up. The reason is a mathematical one. And so the mathematics, we think, is not quite right. The formula needs to take account of length of input and length of output, because the likelihood of error goes up for longer inputs and longer outputs, which seems reasonable. But this is a first step. The probability of a ChatGPT output being correct is 1 minus e raised to the power n. And that means it's this red area here. They are the correct answers. And he thinks that this exponential divergence is not fixable. So ChatGPT is dead, Jack. Because if they can't fix this nonsense, no one will trust ChatGPT, and it will be replaced by something quite different. And no one knows what that is, because the 4 large language models, which is what ChatGPT is, the Google one, the Bing one, I've forgotten, the Facebook one, I guess, they all use the same principles, and they all have the same error problem. They all generate stuff that they make up. All right, now that's the misery of ChatGPT, and it should feel miserable now because I just declared it dead. And I should really be I should be shorting stock, which relies on ChatGPT being alive in, say, 6 months, but I'm not doing that. All right, so let's see how it works and why it is fantastic, why it's a miracle which surprised me. So I'm not pleased with it at all, but it did something which is important. So how did we beat Go? The answer is through an AI method called reinforcement learning, which is a method which works well for games like Go. And the way it works is that for a game like you can define a reward system for each move, and it can be a reward system where the rewards can be assigned by the computer. Now, if you can do that, you can play the game over and over again, billions of times, inside the computer. You don't need human beings. So they're still trying to crack the game of Dota 2, which is apparently a leading e-sport game. I have no idea what e-sport means, but Dota 2 exists. They still haven't cracked it. But they're trying to crack it with a software algorithm called OpenAI 5, which usually wins against humans. And this can play 180 years worth of Dota 2 games in a single day. If you can do that, you can perform miracles in principles such as beating Dota 2. So, can you do it for conversation? 3 months ago, I would have said no, impossible. And I just said it 10 minutes ago. ChatGPT showed how you can apply reinforcement learning to what looks like conversations. Now, how did it do that? So what that means is that we are doing a little bit like emulating human will, because the AlphaGo has to want to win the game of Go in some sense of want. It has to emulate the kind of want that you have when you play a game and want to win. So how does it work? Well, you need a reward system. And I put this in, that's what I used to believe. I still believe it, really, but ChatGPT has unsettled my conviction. So ChatGPT found a way to use reinforcement learning to emulate two-person human conversation inside a computer. And it says here, this is a big deal. And I mean that in a positive way. Now, how does ChatGPT work? You give it any string, and it will work out from its really powerful knowledge of language what the likeliest next syllable is. And that's why it sometimes takes time when it's chatting, as it were. So if you say the best thing about AI is its ability to, then it will say learn, because that's the next most probable output. And now it doesn't always take the most probable, because if it did, it would go around in circles. So sometimes it has a random kick down the hierarchy. All right, now, notice that it doesn't understand anything. It just has an incredibly powerful knowledge of the patterns of language, which enables it to know what the next syllable will be, most likely, after any given string. And so this is how it was built. So the first part is creating this wonderful patterned model of language, not just English, but other languages too. And I won't talk about that. That's the same kind of training that you find in Google Translate. There are then 3 steps which I'll go through one by one. So we have prompts, and these come from Bing. So they're Bing questions. We don't know what they are, and that's a little bit fishy. So some people would like to see the prompts, because ChatGPT 4 is claiming that it can beat humans in medical exams. And some people think that the answers to the medical exam questions were in the prompt database that was used to train ChatGPT, in which case the being able to beat humans would be worth nothing. And then you have people. Some people say it was 40 contractors, but again, that's a secret. It may have been many more. They were all in India, so they didn't cost as much as if they'd been in Zurich, for instance. And they were hired to write responses to those prompts. Now, so when was Michael Jackson born? That kind of prompt, and many other prompts, but only a limited number. And we don't know what they are, but some people say 13,000 prompts. So that's the first step. Now the second step, so you've got the prompts from Bing, and you've got the outputs from the people in India who are paid to respond to these prompts, producing text. Then the next stage is that you pay a labeler, it's called, but it means an evaluator, to rank the outputs created in the first stage. Now, you can't rank outputs when you're talking to your spouse in a conversation. And that's why we can't create a reward system for conversation, because you can't rank outputs in conversations. But the ChatGPT found a way to rank outputs by paying somebody to label them with a score of 1, 2, 3, or 4 points. So 4 points means it's a good output, and 1 point means it's a bad output. And I believe that the reason why ChatGPT very often says honestly, I don't know the answer to your question. So it didn't say, I have no idea what the Orna Loch is. It told me to think about the Orna Loch shaft, which has all kinds of rivers running through it and doesn't exist. Why did it go to that trouble of giving me all this tourist information? Because the labelers, poor things, think that a response which says, I don't know what you want, I'm sorry, is less reward worthy than a long list of tourism information about a non-existing village, because it's a long list of tourist information. That must be worth 4 points. And so ChatGPT basically is being bribed by the labelers to reward long outputs, which are kind and gentle. And so this is why it throws up so much rubbish. The machine will always try to have nice, friendly output. But the machine can play response, prompt, response games with itself billions of times every day for weeks. And that is what it did, and it cost a lot of money to do all that training. And then it can give answers. That's how it does it. And so the lesson